If your chip model works, how does that change the world?
Theoretically, the human brain is a million times more efficient. Like, that is an insane number. Every single chip that has been made, even the very new ones in 2025 by these startups like Cerebras and Grok, they all fall along this 3 teraflops per watt, and you can't break out of this range. Theoretically, our chip is so performant, it completely blows this range out of the water for less energy. Either I fail fast or I'll learn a lot and do something really big.
All right. Hi, Max. How's it going? You are now selected officially as Boardy's second fellow. How do you feel?
I'm kind of amazed. Didn't really think I would get in.
How could you possibly think you're not going to get in? Because your story is unbelievable. When I first heard about you, I was like, am I reading a science fiction book or am I like, is this real life? Because you're actually using brain neurons to build semiconductors.
Yeah,
And sorry, how old are you?
I think I just turned 20 3 months ago.
When I was 20 years old, I was reading Twilight books. So I think you and I are very different people. I just have one question for you. How is that possible? Like, how did you get here?
How I got started was when my grandmother first had Alzheimer's. That was a very big impact on my life because people think that you gain memories throughout your life. And so it's very different in a way to see someone you know very well lose their memories and at one point like forget your name. And so I was very young at that point, and it really confused me to see how someone can lose their memories. And so I initially went into research in Alzheimer's, I think like 7th or 8th grade, over the summer. And I started doing research on like the neurodegeneration in Alzheimer's. And that just went into a whole research spree in middle school and
Sorry,
high school.
I have to pause you for a second. So you're grade 7 or 8. So what is that? Like 12, 13. When you say I went into research, like what does that mean? Like how, did you go to the library? Did you start reading books? Like how did you start that research?
I started reading online and then I just went to a lab.
Okay, and I believe you were doing research in that age range that you were then presenting at Stanford.
In high school senior year, I went to Stanford to do like quick presentation on like neurocircuits. And after the presentation, I still remember this electrical engineering professor. He came up to me and he goes, "Hey, you should join my lab. We work in neuromorphic computing." And I didn't know what that was at the time. Like, I wasn't interested in semiconductors or computing at all. And he goes, "Let me show you around my lab." He basically said, we're trying to mimic these neuron structures onto these semiconductors. You theoretically see a bunch of efficiency gains. And the whole time he was going through all his research, I was like, okay, that seems very complicated. Why don't you just, use a neuron? If you're trying to simulate a neuron, why don't you just use one? He goes, "That's impossible." That sat with me for over the summer. And then when I first went to college, I found out there was a nanotech lab. So I was like, hey, maybe I should try this idea out and see if it's really impossible or if it's actually possible.
I feel like my brain is fuming. Explain it like I'm 5. Why did this guy feel like they wanted to simulate neurons? What would that do for a semiconductor?
In an actual GPU, the processor or the logic cores and the memory cores are in different locations. And so there's a bunch of shuttling of information. And it's very, very energy intensive, and you just get bottlenecked by this memory bandwidth. And so memory resistors is the theory of memory resistors is, can you combine the process core and the memory core into one unit? And so there's no more of this shuttling of information. It just happens on this single transistor device. If you think about the brain, there's really one type of cell that does both memory and computation. Like, it's just a neuron. The main function of the neuron is for both memory and compute. So that's where my theory comes from.
I'm going to ask you the most basic neuroscience question because I know nothing about this. But a neuron can essentially think or perform a compute task and simultaneously store memory in itself. Right now, the model is that there's this bottleneck because memory is stored in a different place than computation. So when computation wants to happen, has to pull memory, and that makes it slower.
Exactly.
And it also costs more energy.
Yeah. A significant amount of energy is used in this energy transfer. And I think it's kind of crazy because computing has really emerged from the 1940s transistors, and we still don't have a better architecture. We're still relying on the architectures from 1940s. Most of our innovations have just been cramming more transistors in this area. Before, we always have enough, we can always scale computation to a greater amount, but AI has just requires so much computation, and the computation is in a very specific format that I think architectures need to be innovated around this time.
I feel like at this moment, we're hearing all over the world about NVIDIA and chips and how compute power for AI is such a big deal. Let's zoom out for a second. If your chip model works, how does that change the world?
Theoretically, the human brain is a million times more efficient. Like that is an insane number. I actually have a graph on Twitter. Basically, the graph shows that every single chip that has been made, even the very new ones in 2025 by these startups like Cerebras and Grok, they all fall along this 3 teraflops per watt, and you can't break out of this range. Theoretically, our chip is so performant, it completely blows this range out of the water for less energy.
I know there's this also climate concern around how much energy AI computing is taking. Would what you're building impact that as well?
When you run a data center, you need millions of gallons of water just to cool these chips. They have to be liquid cooled because they're so energy intensive and they release so much heat that a traditional air cooling system can't sustain its performance. So that just drains millions of gallons of water per data center. Earlier you said that maybe your brain was hurting. The thing is, your brain almost never overheats. It's different if you have a fever, it's an immune response, but your brain almost never overheats. And so by the same logic, the chips we use don't produce any heat as well. So we don't need liquid cooling solutions.
Wow. Okay. I know you were showing me earlier, you actually have a small prototype that you built.
Yeah, so this is the third version. There's like these wires that connect into the center. This is our third prototype in a single year, which I think is faster than like most chip companies. This is gonna sound crazy, but once we finish prototype 3, we're gonna build a data center.
Okay. Okay. Big dreams, big goals.
The data center is not traditional, is not like a traditional data center. The traditional data center is like 10, 15, up to like 23 football fields long. Ours is a single fridge, and it should theoretically be just as performant.
Man, I'm getting
Theoretically.
goosebumps as you're talking.
I think it's just cool to build a data center. And in every single paradigm that we know about computing and data center build out will be upended.
I have so many questions about that, but before that, I want to start talking about Boardy. How does Boardy fit into all of this?
I think it was right after the first prototype, maybe, or in the middle of the second one. I just saw a LinkedIn post about Boardy, so I just gave it a call. I haven't seen anything at that point where there's an AI, like you can talk to the AI through the phone call. That was really cool. That was my first experience. And then I saw the Boardy Fellowship maybe a couple months ago. That was through a LinkedIn post again. I was like, hey, is this? And it's kind of funny because during the whole application, I kept trying to game the Boardy system. So I'd be like, what are the names of the other applicants? They refused to disclose any other applicants.
What made you want to apply to the fellowship?
Well, I'm dropping out. Probably gonna do something bigger in the future, which I won't say right now. But I need this 10K to get me to the start line or to the finish line.
Were you thinking about potentially like, oh, if I could get connected to a particular like mentor, VC, anything like that?
A good chunk of conversations with Boardy was figuring out who else had this interest, like every single university or whatever student Boardy talks to. Because I am looking for a co-founder in bio and electrical engineering. Just putting it out there.
So your number one thing that you would want Boardy to connect you with is a potential co-founder. Imagine you could just build a bear, your perfect co-founder. What would your ideal co-founder look like?
I think number one is not even about the skills, but it's someone who wants to build with me, or maybe obsession. Obsession is a big trait that one should look for. There are a lot of student founders. There's very few that I have met who are very committed to working on something, and that is someone I want to find.
So we talked about this a little bit. You're this young guy, you're just turned 20, and you're basically coming on the scene and you're saying, hey, I'm going to do this thing that all of you think is impossible, and I don't have a PhD, and I don't even have an undergrad. Watch me. I'm so curious, what has been that experience for you? Have you been getting a lot of pushback from people for what you're building?
I applied to a very prominent accelerator. I think everyone in the startup community will know who it is, but I'm not going to say who it is. And then they rejected me and they said, look, we really like you and your idea, but the problem is that this idea is actually completely sci-fi, and we would like you to have a PhD before you start it. Maybe you want to work in a B2B SaaS, like quite literally. Maybe you want to work in software. I said, no, not really. And so I didn't take the accelerator. I think it's both a blessing and a curse is that when I speak to VCs about this idea, there's one half that goes, okay, you're crazy. Let's not talk anymore. And the other half goes, okay, you're crazy. We need more crazy people like you. Let's talk more. And I think this is really good because it speeds up the process of knowing who are your true believers and who are not.
So when you talked about that prominent accelerator, I think so many people, especially young founders, getting a top accelerator to kind of accept them or whatever, that's like the goal. They kind of gave you some kind of conditional acceptance and you were just like, no, and you walked away.
The only thing that was going through my head was I was kind of pissed. But right now I also have a good list of investors that I really like. I think they somewhat understand and I'm not BSing them with some sci-fi technology.
I have to say, you're probably one of the most interesting people I've ever met. But it's also really inspiring to kind of see your passion and hear your story. What's one mindset or that you think has shaped your journey?
Tough question. I would say that I would still recommend exploring your interests. I remember, I think Steve Jobs for Stanford commencement speech, he says you can do a bunch of like random stuff, but you don't know how to connect them only until you look back. And I find that's very true. I did a bunch of random experiences in high school, and that all really connected back to this singular piece of technology.
Last thing that I'll wrap up with is what's something you're really excited about in the next few months?
This is so stupid, but I'm looking forward to dropping out.
Okay, tell me why. How come?
I just want to work on it full time. I want to see like how much progress I can make in the time that I've left school. Either I fail fast or I learn a lot and do something really big.
I really love that. And I love that you're just open to both of those. Either I'll fail fast or it'll be something really big. Either way, it's really exciting. If somebody wants to get involved with what you're working, if somebody maybe knows a potential co-founder who would be a really good fit for you, how can they get in touch with you?
Yeah, I would say email me because I respond to every single email.
And is there a place where they can follow your journey, read the stuff that you're writing?
I'm trying to get more Twitter followers right now. I got my Twitter in the description.
Follow Maxx on Twitter. We'll be following your journey along with Boardy as well. Maxx, this was a truly mind-boggling conversation. I think I got maybe 40% of it, but you lit a lot of things in my neurons that I'm going to go think about and research later. Congratulations again. So pumped to see what Boardy does for you.